Hi, geometry folks. Happy to be bringing you this video. I hope that you are well. Here is a warm-up for you. The question is, for number 1 and number 2, do you have enough information to solve for x? And if so, go ahead and solve. So why don't you pause this video and do that warm-up. Alrighty. So hopefully you were able to answer yes to number 1. Yes, you have enough information to solve for x, because anytime you have a right triangle and you have the length of 2 sides, you can always find the third, because you have our good friend, the Pythagorean theorem, a squared plus b squared equals c squared. And as long as you put the numbers in the right place and calculate correctly, you're going to be able to find the length of that third side. Now, remembering that c is always where you put the hypotenuse, we're going to be able to call this side over here that's across from the right angle that hypotenuse, and then the other side is A and the other side is B, and those guys are pretty much interchangeable. Labeling the sides of your right triangle with its pieces can be really helpful in Pythagorean theorem kinds of problems. So now we kind of know where we're going to put the numbers. Well, if A is 55, I'm probably going to run out of room, but that's all right, plus x squared, because that's what we have in for B, and then C is 64 squared. We can start to solve this. I'm going to grab a calculator real quick. 55 squared, 55 squared is, oh wow, 3025 plus x squared equals 64 squared, which is going to be huge. Nope, wrong number. 64 squared, 4,096. Wow, why didn't I leave myself more room? You might wonder. I'm wondering the same. How about I extend this page out a little bit? I'm going to move this down to here, and we have 3025 plus x squared equals 4096. And now the next step is to subtract 3025 from both sides, creating this cancellation, and we have x squared equals 4096 minus 3025, and we get 1071. And then the last step is to take the square root of both sides. The square root of x squared is, of course, x, and the square root of 1071 is a decimal if you plug it into a calculator. And at this point, it's okay. You know, we've been talking about using square root numbers, and we can start moving away from that again because we're going to be using decimals for our trigonometry that we're about to talk about today. So I'm just going to say that x is about 32.73 3 units, and we are, oh, nope, it's meters because it's indicated as meters. And we're done with that one. Okay, so now looking at number 2. It says, do you have enough information to solve for x? If so, solve. Well, what we have is a right triangle, so that's a good sign. We have one side length. We don't know anything about this side, and we don't know anything about this side either, because it's what we're trying to find. So we can't use Pythagorean theorem because, you know, you need 2 sides in order to do Pythagorean theorem. And then I know that this angle here is 90 degrees, and I know that this angle here is 20 degrees, which would lead me to believe that this angle is 70 degrees, which it is, because 180 minus 90 minus 20 is 70, but that doesn't help me solve for x. I mean, I can get good information out of this, but it doesn't seem like I can solve for x. And so the answer to this one is no. But by the end of this lesson, the answer will be yes. Okay. Update that notebook. Get that notebook out, pause this video, write questions, write summary. Do it. Okay, let's dive in, y'all. Essential question, how can you find side lengths if you know angle measures? The topic is trigonometric ratios. Friends, we are going to study some trig, and I am so excited about it. It's one of my favorite things to teach people because, well, I'll tell you. Because right triangle trigonometry is very cool. It is actually the study of relationships between the sides and the angles of right triangles. So far, if you know two angles of any triangle, you can always get the third because you're just going to subtract from 180. Also, if you know two sides, you can get the third if it's a right triangle because you can use Pythagorean theorem. But if you have one side length and one angle measure at this point, you can't really do much, but right triangle trigonometry is the way to do it. Also, trigonometry is just like super cool and useful. It's like used all the time out there in the real world. Plus, you sound smart when you talk it, and you look smart when you do it. And man, it's actually a whole lot simpler than it seems, but it makes you look good. So why not, right? Early mathematicians discovered that there was a predictable relationship between angles of right triangles and their sides. And it turns out you already know a couple of these relationships. For example, this triangle right here is a 45, 45, 90. And we already know that if you know one side, you instantly know the other, and you also know the hypotenuse because you just stick it next to the square root of 2. Now, we could take that 5 times the square root of 2. Let's see, square root of 2 times 5, and give it a decimal approximation, and that's about, uh, that's not right, 2 square root times 5. It's about 7, about 7.07-ish, okay? So we know that if this side length is 5 and if that side length is 5, then this hypotenuse is 5 times the square root of 2, or about 7.07 units. We already know that relationship. Furthermore, we know about 30, 60, 90 triangles, which is this kind right here. We know that if we know this short side, then we instantly know the other two, because in a 30, 60, 90 triangle, you take the short side, you multiply it by 2, and you get the hypotenuse. So we know the hypotenuse has a length of 10. And furthermore, that side that's left over, we just take the short side of 5 and stick it next to the square root of 3. And this also has a decimal approximation. We're going to take the square root of 3 and then multiply it by 5. And I get like 8.66-ish. So we can tell the sides, all kinds of things about right triangles if we know about one side length and one angle measure, one side length and one angle measure in two particular types of right triangles, the 30, 60, 90 and the isosceles right triangle, or the 45, 45, 90. But triangles don't just exist like that. I mean, you have all kinds of right triangles. What if the angles aren't 45, 45, 90? What if they aren't 30, 60, 90? What do you do then? Well, the answer is, friends, you do trig. That's what you do. The relationships in right triangles are called trigonometric ratios. They're these entirely predictable relationships. But before we get there, let's have a few definitions. So we're still working in right triangles, and when we're talking about trigonometry, are going to have some angle that we know. We're going to call this theta, the angle. It's the angle we know or want to know. Theta just turns out to be a variable, just like x is. In an algebra problem, theta is a variable, and it's some angle measure that we either know or want to know. Wow, that's not making a theta. There we go, that's better. Now, whenever we have a theta, an angle that we're talking about, the leg that is across from theta is called the opposite. So as soon as you know theta, you know the opposite leg. The opposite leg is the leg across from theta, this angle that you either know the measure of or you don't know and you have to find out. The hypotenuse is the side of the triangle that's directly across from the right angle. The side across from the right angle, as it's always been, leaving, well, so this one's the hypotenuse, leaving another side that's called the adjacent leg. The adjacent leg is the one that's left. So it's kind of a process. First, you look at your angle that you're working with. We're going to call it theta, but sometimes there's a number there. And then you're going to look directly across from theta to find your opposite side. The hypotenuse has always been the hypotenuse, and then the one that's left is called the adjacent side. And knowing these labels are going to be vitally important to being able to set up your trig ratios. Because trig ratios are entirely dependent on those sides. The trig ratios have some strange names. There's the sine, which is the name of that ratio. There's the cosine, which is the name of a ratio, and there's the tangent. And these names have abbreviations. There's sin, cos, and tan, and I bet you've seen those buttons on your calculator because that's what those buttons do. They calculate these ratios for you. Now, the way that the sine ratio works is that whatever theta you have an opposite, and a hypotenuse, and an adjacent. And you take the measures of those legs and you stack them up. The sine of an angle is the opposite side over the hypotenuse. You take the opposite side and you divide it by the hypotenuse. The cosine is the adjacent side divided by the hypotenuse, and the tangent is the opposite side divided by the adjacent. Now, don't freak out. Right now, you're like, wait, what? It's fine. Just let it wash over you a little bit. It's going to take some hearing this language a little bit, working with it. Right now is the hard part. When all this stuff is being like thrown at you, you're going to be okay. Trust me. Because I have a little trick for you. There's a way to remember these relationships, and we say it so, ka, toa. And so can be translated as the sine, let me write this all out. The sine of the angle is the opposite over the hypotenuse. So, SOH, the sine of the angle, is the opposite over the hypotenuse. And then we have ka, and this literally says the cosine of the angle is the adjacent over the hypotenuse. These little sentences are telling you how to set up an equation, and you'll see that here in just a bit, so hang on. The cosine is the adjacent over the hypotenuse. And the last one, tangent, you can remember with toa, and that is the tangent of the angle is the opposite over the adjacent. Again, what these sentences are doing right now is confusing you. But what they will do very soon is tell you exactly how to write an equation. And I'm going to show you all of that. So don't worry. The tangent is the opposite over the adjacent. I'm just introducing the idea of being able to remember these relationships by remembering SOHCAHTOA. SOHCAHTOA. Right. So now that we've talked about that, these relationships, trigonometric ratios, are so true that they're programmed into your calculator and can be looked up even if you don't have a calculator because there's lists of them. So first, let's talk about calculators. When you get your calculator out, you're going to see a sin, cos, and tan button, and I bet you've messed with it before and got some crazy weird decimals, but what you didn't realize was that what you were doing was calculating trigonometric ratios. That's what those are. That's what those buttons do. It is vitally important that your phone, that's funny, calculator, even if it is on your phone, be in degree mode. And honestly, whatever kind of calculator you might have to Google it to figure out how to make that happen online. We can meet during office hours, I can help, but having your calculator in degree mode is vitally important. Now, on my iPhone, that's the calculator I use, I turn it sideways, and I'm pretty sure it's automatically in degree mode. But down in the bottom left, there's a button that says rad. And when I click it, it says deg. And then when I click it, and when I click rad, it says rad up in the display part where the numbers pop up. And then when I click deg, that stops. Oh, my phone's ringing. My phone always rings when I make videos, always. Anyway, play with it. As long as rad is not displaying in the top part, then you're good. Should be good. Yeah, again, we can chat about it. It's a big deal, so make sure that your calculator is in degree mode. Most calculators will have somewhere in the display either a D or a DEG, something like that. If you don't have a calculator, these relationships are so true that you can look them up on a table. And in fact, mathematicians all the way back to ancient Greece knew about trig ratios, and they didn't have calculators. And so what they did was they looked up these things in a table. I'm going to show you the table in just a second. You can get the sine, cosine, or tangent of angles by finding the angle measure on the far left and then looking to the right in that row. I'm going to put trig tables into Google Classroom so you can use them if you want to. And here is what the charts look like. So this is a pretty typical trig ratio chart. Notice that there are angle measures in this column. And then if you want to know the sine of that angle, it's right there. The cosine of that angle is in this column, and the tangent of that angle is in this column. And notice this one goes up to 25, and then this one starts again at 46. That's because I copied it wrong, but the next page will have the rest of them. So, for example, if you want to know the cosine of a 15-degree angle, there's 15, and there's the cosine, and that's the number you would use, 0.9659. That's the cosine of 15 degrees. If you want to know the tangent of a 65-degree angle, you could look it up because it's right here, and that's the number you would use in your calculations. Now, the next page has the rest of them. Here's number 26, and then this goes to 45, and then starting again at 71, and it goes right up to 89. It doesn't go to 90 because, well, it doesn't work after that. But if you wanted a 35-degree angle, if you had a 35-degree angle and you wanted to know the sine of it, you could look it up on this chart. And again, I will be putting these on Google Classroom. They could be really handy. If you can't figure out how to get your calculator into degree mode, then these charts, you just look stuff up. It's fine. All right. So, do trigonometric ratios work? Let's find out. So I'm going to do this problem, but let's talk about what we already know. This is a 30, 60, 90 triangle, right? which means if this side is 6, it's the short side, then this hypotenuse must measure 12, and this side down here must measure 6 times the square root of 3, right? Which is approximately, I'm going to plug that into a calculator. Oops, error. Square root of 3, come on, times 6 is 10.39-ish, about 10.39-ish. Okay, so that's what we know about a 30, 60, 90 triangle. If the short side is 6, the hypotenuse is 12, and the other side is about 10.39 units. Now this, I'm going to use a trigonometric ratio and show you that this hypotenuse number of 12 is correct using trig. So 30 is my theta, and this is what I'm going to start with. Then that means that across from that 30-degree angle, my theta is the opposite side, so I'm going to label it with an O. The hypotenuse is what it's always been, the H, and then this last side I'm going to label with an A for adjacent. For me, that's always the first step in starting a trig problem. I label the sides. All right, now I want this hypotenuse. I'm pretending I don't know that it's 12 units long. I want this, and I have information about the opposite side. And since I have the hypotenuse and I want the opposite side, I need to pick the correct trig ratio to use. It's going to be the one with the O and the H in it because I have the hypotenuse and I want the opposite side, so I'm going to choose the sine. The sine of the angle is the opposite over the hypotenuse. The sine of the angle is the opposite over the hypotenuse. The sine of the angle is the opposite over the hypotenuse. That's how you use that sentence to set this up. Okay? So, a different look at how to solve this problem. We already know that that hypotenuse is 12 units long because that's how it works in 30, 60, 90 triangles. We're seeing if the trigonometric ratios confirm this. And I use that sentence, the sine of the angle is the opposite over the hypotenuse, to set up an equation. And you're about to see this about a dozen times, so don't stress out. This is just the first time, and that's why it looks weird. Okay. So sine of 30 is something that I can either look up in that table or punch into my calculator. I can push the sine button, or no, I have to do it this way in this calculator. I have to do 30 and then punch the sine button, and I get 0.5. Now if I go back to our tables and I find a 30-degree angle, this is the sine, there it is, 0.5. I can just look it up. That's a number. Remember how numbers can look weird? Sine of 30 is a number, and it has a value of 0.5 equals 6 over the hypotenuse. Now, I want to get I'm trying to solve for the hypotenuse, and so what I'm going to do is I'm going to multiply both sides by my variable h, and I get 0.5h equals 6 because these cancel. Now I'm going to divide both sides by 0.5. These cancel, and my hypotenuse is 6 divided by 0.5, or 12, which is exactly what we thought it was going to be. So when you were setting up 30, 60, 90 triangles, you were doing trig. It was just a shortcut. And now we're kind of pulling that open and looking at it from all perspectives. So that brings us back to the warm-up. This is the triangle we saw in the warm-up where we had a length of 410 feet and an angle degree of 20, and I said, do you have enough to solve for the hypotenuse of this triangle? And we had to say no, but now we do have what we need. So let's do this. Here is theta. Yes? Theta is that angle that we're looking at. And so directly across from theta, we have a side. That side we can call the opposite because it's opposite theta. The hypotenuse is always the same. It's the one across from the 90-degree angle, and the one that's left is the adjacent. We have three trig ratios. We have the sine, we have the cosine, and we have the tangent. And they can be remembered by remembering so, ka, toa. And we need to pick the right one. Well, notice that we have information about the opposite side, and we want information about the hypotenuse. So we're going to pick the sine again, because the cosine has information about the adjacent, and we don't care about that, and the tangent wants information about the adjacent, and we don't care about that, and so we're going to use the sine ratio. Now, what this little abbreviation says is the sine of the angle is the opposite over the hypotenuse. So we're going to turn that into an equation. The sine of the angle is the opposite over the hypotenuse. That's why it helps us remember. So now we just need to start turning this into numbers. Well, sine of 20, you can push that buttons on your calculator, 20, and then sine, and I get 0.34. If I had to go and look it up in a table, I could do that. Let's see, where's 20? Here it is. The sine is 0.34-ish. Close enough. We're having to round a bunch, but that's okay. Equals 40 over x. Now, if I want to clear out that x, whenever you want to clear out a fraction, you multiply by what's in the denominator. So I'm going to multiply both sides by x. And this side I have 0.34x equals 40. And then I'm just going to divide both sides by 0.34. Give myself a little more room here. Creating this cancellation, I have x equals 40 divided by 0.34, which is 117.65-ish. And so I know now, that this hypotenuse measures 117.65. I did something wrong. Because the hypotenuse is the longest side. Do you see how this says 410 and this says 40? Let's go back to this step right here. Diggity darn it. We were good up till then. Let's see, I'm just going to go right back to here. I knew there was something wrong once that 117.5 popped up, because the hypotenuse is always the longest side, and 117 isn't longer than 410. So I checked my work and I found that I'd written it wrong. So the sine of 20 is still 0.34-ish, equals 410 over x. Now I'm going to multiply both sides by x. I have 0.34x equals, these cancel, so I get 410. Now dividing both sides by 0.34 gives me x equals 410 divided by 0.34 is 1205.88. Ugh, that is much better. And that is feet. And there you go. So trig looks really weird, and it can freak you out because there's so many new things to think about. But the more you do it, the more you're going to notice that it's a very predictable process, and it really does. It's a super efficient way of finding side lengths in right triangles when all you know is one side length and one angle measure. So here are those steps. Notice that all you know about a right triangle is one side length and one angle measure. That's the thing you got to look for first. Then you know you're going to use trig. From there, identify those sides. Physically write it on your right triangle, the opposite side, the hypotenuse, and the adjacent. Then you're going to want to notice what you have and what you want. And then pick the correct trig ratio based on what you have and what you want. Use SOHCAHTOA to help you set up that ratio, and then solve using your calculator in degree mode or look it up on the trig tables. That's how you do this. So let's do another couple of problems. All right, so we need to find the length of side A there in that right triangle. So the first step is to notice that all you know about a right triangle is that one side length and one angle measure. Well, I know one angle measure is 82, and I know one side length is 20, and that's all I know, so I'm going to use trig. The next thing to do is to identify the sides. So 82 is our theta, which means directly across from theta is the 20 centimeters. That is our opposite side. The hypotenuse is exactly the same as it's always been, and labeled A is our adjacent side. So we have identified the sides. Now we're going to notice what we have and what we want. We have the opposite side. We want the adjacent side. So we've noticed what we have and what we want. Now we're going to pick the correct trig ratio based on that. So we know that there are three trig ratios: the sine, the cosine, and the tangent. And we can remember them by remembering SO, CA, TOA. Now we have the opposite and we want the adjacent. So sine is out because it has the opposite and the hypotenuse. Cosine is also out because it's adjacent and hypotenuse. Tangent is the only one that deals with opposite and adjacent. So that is the trig ratio we're going to choose. Now we're going to use TOA to help us set up this equation. So TOA means the tangent of the angle is the opposite over the adjacent. The tangent of the angle, I wrote over it so I don't know what it is. Oh, it's 82. Is, equal sign as always is, the opposite, which is 20, over the adjacent, which is A. And now it's time to solve. We've got the ratio set up, and now we just solve using, I'm going to use my calculator, but you could look it up in the trig table. In my calculator, in order to find the tangent of 82, I have to press in the number 82 and then press tan, and I get 7.12-ish. Good enough, close enough. I always round to 2 decimal places. I don't know, it's just my thing. In some calculators, you have to press the tan button and then 82, so it all depends on your calculator, equals 20 over A. And then to clear the denominator, we're going to multiply both sides by it. And so we have 7.12A equals 20, because these guys cancel. Dividing both sides by 7.12 gives us that A equals 20 divided by 7.12 is 2.8. Is that right? 20 divided by 7.12. Yep, 2.8. And there you go. There's the length of your side. Centimeters. So just keep following these steps. It'll walk you through how to do right triangle trig, and that's all there is to it. Let's do another one. Now we're going to find the length of Q. First of all, I noticed that about my right triangle is that I only have one side length and one angle measure. So I'm going to identify those sides. Now my theta is 27, and directly across from that 27 is the opposite side, so I'm going to label that O. The hypotenuse is always across from the 90-degree angle, leaving this other side to be the adjacent, and now I have identified the sides. Now what I notice is what I have is the adjacent, and what I want is the hypotenuse. So I'm going to pick the correct trig ratio by remembering that I know that there's a sine, a cosine, and a tangent. And I can remember them by remembering SO, CA, TOA. Okay, well, I have the adjacent and I have the hypotenuse. So sine is out because it's got the opposite and I don't know anything about that. And tangent is also out because it's got the opposite in it. So cosine is the one that I'm going to use this time. So I have picked the correct trig ratio. Now I'm going to use the cosine of the angle is the adjacent over the hypotenuse to set up my ratio. The cosine of the angle is the adjacent 17 over the hypotenuse Q. And we're off and running. So now I'm going to solve. Let's see, 27 cos is 0.89, and that equals 17 over Q. I'm going to multiply both sides by Q and get 0.89Q equals 17 because these cancel. Now dividing both sides by 0.89 gives me Q equals 17 divided by 0.89 is 19.1 meters. Done. And that's the length of that hypotenuse. We did it. Pretty cool, huh? It looks weird, but once you get used to it, it's kind of a breeze. Okay. Well, there you have it. That's how you do trigonometry, friends. I hope that this video has been helpful. Your assignment is on quizzes, but it's not a quiz. Please do let me help you if I can. Have a wonderful day, y'all. Bye.